Good morning, sir. I am G. Vijay Chandra Prasad. My roll number is 2295180117. Subject SSDD. My topic is about effect of geometric and material properties and behavior of axially loaded concrete filled stainless and introduction. Part number 1. The behavior of axially loaded concrete filled stainless steel CFSS. Column is influenced significantly by both geometric and material properties. Point number 2. Understanding these effects is crucial for optimizing the design and performance of CFSS structures. Point number 3. This presents will explore how various factors impact the strength and stability of axially loaded CFSS columns. Overview of concrete filled stainless steel columns. Point number 1. Concrete stainless steel columns combine the compressive strength of concrete with tensile strength of stainless steel. Point number 2. The composite action enhance the overall performance of structural elements under axial loads. Point number 3. The design of CFSS column must consider both the stainless steel tube and the concrete core properties. Geometric properties. Point number 1. The geometric properties such as the diameter and wall thickness of the stainless steel tube play a significant role in load bearing capacity. The slenderness ratio, which compare the effective length to the radius of gradation, affects buckling behavior. Point number 3. A well designed geometry can optimize the interaction between the concrete and stainless steel tube. Material properties of stainless steel column. Point number 1. The yield strength and ductility of stainless steel are critical in determining the overall performance of CFSS columns. Point number 2, higher yield strength can lead to increased load bearing capacities under axial loads. Point number 3, the choice of stainless steel grade can also influence resistance to corrosion and fatigue. Material properties of concrete. Point number 1, the compressive strength can modulus of elasticity of concrete significantly affect the performance of CFSS columns. Point number 2, different type of concrete such as high strength or lightweight concrete can alter the overall behavior under axial loads. Point number 3, the bond between concrete and stainless steel is issue of effective load transfer and composite action. Interaction between concrete and stainless steel. One, the interaction between column, concrete core and stainless steel shell is essential for ensuring structural integrity. Point number 2, adequate bond strength between the two materials is necessary to prevent slippage under load. Point number 3, the coefficient provided by the stainless steel tube enhance the compressive strength of concrete. Load behavior and failure modes. Point number 1, axially loaded CFSS columns exhibit distinct load behavior patterns based on their geometric and material configurations. Point number 2, common failure mode include buckling of the steel tube, crushing of concrete core and overall instability. Point number 3, understanding this failure mode is crucial for developing design guidelines and safety measure. Design consideration. Point number 1, effective design of CFSS column requires a comprehensive analysis of both geometric and material properties. Point number 2, design codes and standards must account for the unique behavior of CFSS under axial load. Point number 3, collaboration between architects, engineers and material scientists is essential for successful implementation. Case studies and experimental results. Number 1. Numerous experimental studies have been conducted to evaluate the performance of CFSS columns under the axial load. Point number 2. Case studies show that optimizing geometric and material parameters can lead to improved load capacity and durability. Point number 3. The finding contribute reliable data to the ongoing development of designing methodologies for CFSS structures. Conclusion. The behavior of axial loaded concrete filled stainless steel columns is complex and multifaceted. Point number 2. All through understanding the geometric and material properties of machine for effective design and applications. Point number 3. Future research should focus on refining design guidelines and exploring innovative material to enhance CFSS performance. Thank you.